Today's lesson will be more on parallel and perpendicular lines. On Friday, you went through the Desmos activity and hopefully discovered the relationship between parallel and perpendicular lines. Today we'll be using that discovery to write equations of parallel and perpendicular lines. A little review from Friday. We know that parallel lines have the same slope, which means the rise and run is the same. We know perpendicular lines are opposite reciprocals. And how do we do opposite reciprocals? We flip the fraction and change the sign. We had a little song that we could use to remember that. Went something like this. Parallel lines have the same slope, rise and run the same, that's how it goes. Parallel lines have the same slope, rise and run the same, that's how it goes. For perpendicular lines, how do we do that? Perpendicular lines. How do we do that? Flip the fraction, change the sign. We'll do that one again. How do you do that? Perpendicular lines. How do you do that? Flip the fraction, change the sign. We'll ignore that part. Given these certain equations, so this first equation is in slope-intercept form, and if you look to the left on the whiteboard, you can see that slope is just always the number in front of x. In this next one, we see that we're in point slope form. Slope is always the number that's in front of that parenthesis set. The last one is standard form. That's one we just talked about, where we don't have the slope just from the equation. We have to do a little work to find it, and that work involves getting this y by itself. Really what we're doing is turning it into this equation, a y by itself kind of equation. So in order to do that, again, we want to isolate the y. So move your x variable by minusing 3x. What we do to one side, we'll do to the other. Now we have 4y. We need to undo that. We'll divide by 4. What we do to one side, do to the other. And again, your slope is now this in front of the x, which is negative 3/4. All right. So let's take a look at where we're going today with this. So today we're going to write equations. This first example is in point slope form, which is on the left, whiteboard to the left. This equation here, we know that we need to plug in the slope and a point. Here's the information we're given. I have a point. This will be my x1, y1. And I know I need to be parallel to this equation, y equals 2x minus 1. I know that parallel lines have the same slope. So I need to be parallel, have the same slope, which means I need to have a slope of 2. We plug in our slope. We plug in our point. And we'll have our equation. Y minus y equals m, slope, x minus x. Since I was asked for point slope form, I'm done. That is my answer. Give this next one a try. We're given another point, negative 9, 2. That's my x1, y1. Now I want to be parallel to this equation in standard form. So do a little work on your own to find the equation, and find the slope of that equation. Get the y by itself. Go ahead on your paper right now. Minus 5x, what you do to one side, do to the other. Divide by negative 4. What you do to one side, do to the other. The slope of this line ends up being -5 over -4, which we can reduce. Negative over a negative is positive. So the slope of the parallel line is the same. So we have a slope of 5/4. And again, at this point, plug your point in. Plug your slope in. Y minus y equals m times x. I'm minusing a -9. Minus a negative is plus. Next example, we're asked for an equation in slope-intercept form. So we're switching things up a little. Slope-intercept form goes through, this is my point, x1, y1, and it's perpendicular to this equation. So this equation, I'm just going to kind of box this up. This is my slope of this equation. It's 5/3. Perpendicular. I don't want the same slope. I want now to find the perpendicular slope. And how do we do that? Do that, perpendicular lines. How do we do that? Do that. Flip the fraction, change the sign. So we have to flip this fraction. So 5/3 becomes 3/5. Change the sign. This is a positive. So we change it to a negative. The last two problems we did were pretty easy to just plug those values in to my point slope formula. My slope, my point. So I'm going to do that again. Y minus the y, minusing a -4, equals m times x minus the x. So it's easy to plug that in, but we're not quite done because I want my equation in slope-intercept form, which means I need y by itself, y equals. But I can use this equation that I have to get there pretty easily. Just really 2 steps. So we take and distribute this. -3/5 times -9. Go ahead and use a calculator if you need to. If your answer is in a decimal, or excuse me, in a fraction, change it into a decimal using division. If your answer is a decimal, we can leave it like that. Probably a little easier to work with. We get 5.4. I want y by itself, right? So my next step is going to be to -4. What I do to one side, I do to the other. So I get y equals -3/5 x. Clean that up. 5.4 minus 4. And now my equation is in slope-intercept form because I have the y by itself. Perpendicular, I take a look at the slope, still is opposite reciprocal, or I flip the fraction, change the sign. And the last example we'll go through is really similar to this. The information is given in a little bit different format. I'm given a picture of a line, and I'm given a point. And if I read the directions, I say, okay, we want to write an equation in slope-intercept form that passes through this point here, and then is going to be perpendicular to this given line. So first thing we need to do is find the slope of this line that's given to us in order to identify what the perpendicular slope needs to be. So to find the slope of this line, we're going to find 2 nice points on the line. Work it out, count the rise over run. And then we'll put that answer here. Rise over run. Now, if I want to be perpendicular, I'm just going to make a note to myself. I want to be perpendicular. So I don't want this slope. I don't want 1 over 5. I need to, well, how do we do that? Do that perpendicular lines? How do we do that? Do that? We flip the fraction and change the sign. Now, negative 5 over 1 is the same as just negative 5 for your slope. We'll work ourselves through the same process that we've been through. Write your equation in that point slope form first. We have the slope here. We have a point. The coordinates of this point are 1, 2, 3, 4, 5, 6, 1. Now, some of you want to go directly to the slope-intercept form. When I plug in a 6, I get a 1 out. We know our slope is negative 5x. When I plug in a 6, I get a 1 out. You can do that. If you're not sure how to complete that step, then we'll walk through the process up here. Y minus y equals m times x minus x. Again, 2 steps. Distribute. Negative 5 times x. Negative 5 times negative 6, positive 30. Get the y alone. Y equals negative 5x plus 31. Okay, so you have a worksheet that you're going to work on. It is due tomorrow. If you didn't finish the Desmos activity or the quizzes activity from Friday, it's still up on Google Classroom. It would need to be finished by tomorrow for you to get any credit. Have a good day. We'll see you tomorrow. Come in before school if you have any questions on this, and we can get it figured out.